Hi, good morning, dear students. We are going to start the next session of our chapter LCM and HCF. We have discussed the HCF. Now we are going to discuss the LCM. We have done many problems based on the HCF. Okay. You have already studied what is LCM. What is LCM? What is LCM? LCM is least common multiple, right? Least common multiple. So in the HCF it was factor. In case of LCM it is multiple. Let us check. Let us consider a number 4. 4 into 1, you have to note LCM. 4 into 1 is 4. 4 into 2 is 8. 4 into 3 is 12. 4 into 4 is 16. 4 into 5 is 20. We can write up to infinity. Okay, let us consider number 8. 8 into 1 is 8. 8 into 2 is 16. 8 into 3 is 24. 8 into 4 is 32. Okay, we can write up to infinity. We can say 4, 8, 12, 16, 20 are the multiples of 4, right? Then here 8, 16, 24, 32, 40, so and so are the multiples of 8. Here you have to observe some common terms are there. Here it is there. Here also 8. Right. Here 20. Okay, let us write 6 here. Then 24 here. Here 24 is there. Here also 24. Okay. Here we can say many common multiple are there. Common multiple are there. But the 8 is the least multiple. So 8 is the LCM of both 4 and 8. LCM of 4 and 8 is 8 is the LCM. Right. So actually it is the meaning of LCM. LCM is the multiple in which is the least. Okay, what is the purpose of this? We know what is HCF. HCF means in case of HCF, that number divide some number without the remainder. Here what is the fact? Here the LCM is divisible by given numbers without the remainder. Okay, then how to find the LCM? How to find HCF? My dear student, you have to start to find HCF. There are two methods. First one is prime factorization method. Second one is cross division method. Here also in case of LCM, the first one is prime factorization. Prime factorization method. Easy one. Okay, we can have an example. We can say the number 16 and 20. We have to find out the LCM of 16 and 20. Okay. First we have to factorize the 16. Okay. 16, 2, 8, 2, 4, 2, here 2, up to 1. Okay. Then we have to factorize the 20. Then 20 by 2, 10. Again by 2, 5. Again 5 is the factor. Clear? Then what we have to do? We have to write the 16 is equal to 2 raised to 4. Right? Then 20 is equal to, what is 20 actually? The 20 is equal to, here 2 raised to 2 into 5. Right? 2 raised to 2. Because 2 2's are there, then 1 5. Then what is LCM? For the HCF, we have taken the least power. Here we have to take the highest power. It is multiple, so we have to take the, you have to understand that the LCM will be the value of the LCM will be greater than the given number, but the HCM will be lesser than the numbers, right? Then the LCM 2 raised to 4, we have to write the highest power. Here 1 5 is there, here no 5, so we have to write the 5 because 5 raised to 1 is the highest power, right? Then 2 raised to 4. What is 2 raised to 4? 16 into 5. So what is 16 into 5? 5 into 1, 80 is the answer. So LCM is 80. What does it mean? What is the 80 here? We can say that if we divide 80 by 16 and 80 by 20, there will not be any remainder. Actually 160. The 160 can be divisible by 16 and 20. But there is also no any remainder, but it is the least one. So 80 is the LCM. You can say multiples of 80, that is divisible by both 16 and 20, right? Okay, it is the prime factorization method. Then we have to discuss the next method. Okay, next method. What is it? You already know. Next method is common division method. Common division. It is also same as the factorization. Here we have to write both the number in common. Okay, right. It is, I think it is the simple method, easy method. We need to find the prime factorization separately. Okay, we can have 24 and 30. 24 and 30. Okay, we have to find out the LCM. So this purpose we have to write the 24 and 30. 24 and 10. Then we have to find out which is the least common factor. Okay, so which is the smallest factor of 24 and 30? It should be common. So 2 is there. It is the smallest factor. Okay, not multiple, the 2. Then here 12, then 15. Then 2 is possible? No, 2 is not possible. Here 2 is there because it is even, it is not even. So 3 is there as the factor, right? Then 12 by 3, 4. Okay, then here 5. Here any common factor is there? No common factor. Either you can stop here or again you can divide this 4 only. Here there are only 2 terms, so we can stop here, no any problem, because there is no any common factor. So what is LCM? Then LCM is, we have to multiply this 2 into 3 into 4 into 5. It is the LCM. Okay. Then 2 into 5, 10. 10 into this 12. So 120 is the LCM. Right. It is the common division method. It is the common division method. Okay. Let me give 2 questions to you. Right. You have to write the question. Find the LCM. Find the LCM of given number. Find the LCM of given number. Question number 1. Find the LCM. Here A is equal to 2 square into 3 cube into 5. B is equal to, okay, you have to find out both the LCM and HCM because it can be done using the prime factorization. The prime factorization is the method for both LCM and HCM. B is equal to 2 raised to 3 into 7 square. Okay. Find both LCM and HCM. It is a question. Okay. Then question number 2. Find the LCM of 360, 900. One more number is there. Here it is. Then 400. You have to find the LCM of 360, 900 and 400. Here you can use the method common division method. If 3 terms are there, it is better to use the common division method. You have to send me the answer. Okay. Then next we have to discuss relation between LCM and HCM. Relation between LCM and HCM. It is nothing. You have to know that if 2 numbers are there, if n1 and n2 are 2 numbers, then n1 into n2 is equal to LCM into HCM. You have to know it. Okay, enclosing a box. n1 into n2 is equal to LCM into HCM. That means product of 2 numbers is equal to LCM into HCM. Okay, it is the relation. Okay. Let us do some more problem based on the LCM and HCM. Before that, we have to conclude what is LCM and HCM. There are many problems. Let us just discuss in case of the LCM and HCF. Okay, HCF and LCM. LCM and HCF. Okay, you have to note it. Here in the case of LCM, the question will be that find the least number that is divisible by will be there. In case of the HCM, the question find a number that divides. It will be the question. Right. Divisible by divides. Okay. In case of the LCM, it will be multiple. Okay. Multiple. It will be factor. Okay. Here it will be mixing or combining or combining. Mixing or combining. Here it will be what? Separating. You have to understand that value is lesser. Here the value will be larger. Okay. Let me give a question. Problem. Write the question. Find the greatest 4-digit number that is divisible by both 32 and 40. Find the greatest 4-digit number that is divisible by both 32 and 40. My dear student, what is to be found here? LCM or HCF? Definitely it is LCM because divisible by. So we have to find out the LCM of 32 and 40 by the common division method. 2 is that 16, 20 by 2, 8, then 10 by 2, 4, 5, again no any common factor. So we can stop here. If there is one more 8, suppose if 8 is there, if 3 terms are there, 3 numbers are there, one more term will be there. That time we can again divide the 2. So here there is no more 10. So we can stop here. So what is LCM? LCM is equal to 2 into 2 into 2 into 4 into 5. Right. So what is the answer here? 2 into 4, 8 into 2, 8, 4, 8 into 4, 32, 32 into 5. 160 is the answer. So 160 is the LCM. So we can say that 160 into 1, 160 into 2, 160 into 3. These are multiple of 32 and 40. Or this number can be divisible by 32 and 40. But what we have to find here? Here we have to find out the greatest 4-digit number. Greatest 4-digit number. Okay, which is the greatest 4-digit number? 9, 9, 9. But our question is that which is the greatest 4-digit number that is divisible by 32 and 40. So first we have to find out the LCM. Then 9, 9, 9 by 160. We have to divide it by 160, right? Then 9, 9, 9 by 160. What is here? Here 6 is there, right? 0. Then 36, 960. Okay, right. Then here it is 39. Clear? Then one more 9. So 2. Right. 320. Then subtract. We have got 79. Right. So we can say if I subtract 79 from 9, 9, 9, 79 from this one, it is the remainder. If I divide 79 from 9,999, that is divisible by 160, right? Do you have any doubt? If that is a 10 by 3, answer is 3 by 3, 1. If I remove 1 from the 10, if I subtract 1 from the 10, the 9, that is divisible by 3. If I avoid the remainder from the 9,999, that is divisible by the divisor. So here divisor is 160, that is LCM. When we subtract it, here it is 0. Okay, right. 0, then 2, right, 9, 9. So we can say 9,920 is the number that is divisible by both 32 and 40, right? My dear student, this much is LCM and HCM. So we have to do some more problems. Okay, we have finished our content. Okay, we have to write one more thing. Listen. What is LCM and HCF for? Co-prime number. Co-prime number. Okay, in case of the co-prime number, we can say HCF is equal to, what is HCF of co-prime number? 1. HCF is 1. LCM is product of number. We already know what is the product. LCM into HCF is product of number, but here HCF is 1. So definitely LCM will be product of numbers. It is only in case of the co-prime number. You have to just note it. Okay, you can note it. Right. In case of co-prime, HCF is equal to 1. LCM is equal to product of number. Okay. My dear student, there are many problems to do. I will give some more problem. You have to do. We will clear it, and we have to conclude what we have learned in this chapter. What is LCM and HCF? Let me explain that. What is difference of LCM and HCF once again? Okay.
Hello and welcome once again. Today we are going to learn LCM and HCF, which stand for lowest common multiple and highest common factor respectively. Confusing as they may sound, but let me tell you, they are really very simple. So let's begin first by understanding what we mean by a factor and what we mean by a multiple. Look at these two numbers, 4 and 6. Multiply these, their product is 24, as you can see. 4 and 6 are factors of 24, and in turn 24 is a multiple of 4 and 6. Just as these other numbers have 24 as their multiple. So all of these numbers are factors of 24. Likewise, all of these numbers are factors of the number 36. I see some of the numbers in both these lists being common. The biggest or the highest being 12. So the highest common factor or HCF of 24 and 36 is 12. Simple, isn't it? Now let's look at these two numbers, 3 and 5. These are the multiples of 3 and these are multiples of 5. As you can see, unlike factors, the multiples go on and on and on, though not beyond infinity. And voila, there are some common numbers here too. The smallest or the lowest being 15. So the lowest common multiple or LCM of 3 and 5 is 15.
Mr. Roy, but why should we even bother about HCF and LCM?
Good question, Tia. Let us see some practical examples of HCF and LCM in mathematics as well as in real life. Both HCF and LCM are widely used in fractions. While you will learn more about fractions in another session, for now, let me say that HCF is used in simplifying or reducing fractions, and LCM is used in comparison of or operations on fractions. To understand how this concept applies in real life, imagine this situation. Let's suppose there are 18 students in class A and 27 in class B. Each class divides into teams to prepare for an upcoming sports tournament. The winning team from each class plays each other in the final. What would be the biggest possible team size you could divide both these classes into, such that each team has exact same number of students and that no one is left behind? Careful observation would tell you that the answer is 9. Easy. But what if the class A had 204 students and class B had 255 students. What would be the biggest possible team size then? Well, careful observation may not help here. So use highest common factor. The HCF of 204 and 255 is 51. So the team would be 51 students each. Let's take another real life example. Tom takes a coffee break from work every 45 minutes, while Jane breaks every 20 minutes for coffee. They just finished their break. How long before they meet together again for their breaks? Well, the answer lies in the lowest common multiple. The LCM of 45 and 20 is 180, which means they meet after 3 hours. Hope this helped you, Tia.
Yes, Mr. Roy, it did indeed. Thank you.
My dear students, now I think that everything is clear. You know the LCM and HCF. Okay, I will give some more problem. You have to do it. We will meet on the next class. Thank you. Have a nice day.